Okay, so now we will move on to the next part of our lesson. So we are going to learn how to model with differentiation. So in the previous parts, we learned how to interpret the gradient of the curve by looking at the fx curve. We learned previously how to sketch the f dash x curve, right? So that part is done. So now we are going to learn how to model with differentiation. Okay, so what we'll do is we'll directly do it with the sums. I'll directly teach you how to do this from the sums. Look at the first question in exercise 7D. Exercise 7D first question, they tell you find d theta by dt where theta equal t square minus 3d. Okay, this is not a big sum. This is actually a small thing to do here. Basically, you have here theta equal t square minus 3t, right? Theta equals, so this is basically the it looks like similar to y equal x square minus 3. It's just that y is replaced by theta and x is replaced by t. It's the exact same thing. Okay, so then when you differentiate y, we write dy by dx, isn't it? So likewise, your theta is in place of the y. So when you differentiate theta, what do you think we should get? Similar to dy by dx, when I replace when I differentiate, I get here what? D theta by dt. We say we differentiate with respect to t now. Okay, that's why d theta by dt, like you do dy by dx. Okay, theta is the y and t is the x now. Okay, t square differentiation is 2t minus 3. Is that okay? So they are find d theta by dt. So that's it. T square minus 3t. T square minus 3. Okay, 2t minus 3. Okay, question number 2. Find dA by dr where a equals to 2 pi r. Okay, so how do we find dA by dr? Now once again here you need to identify by the way who are your variables and who are the constants. Now here remember a is of course the area, r represents the radius here. So you need to identify here 2 and pi are what? 2 and pi are constants. So you know when you're differentiating, the constants stay aside, right? They stay aside while the variables differentiate. So 2 and pi are constants. Basically, here a is like y and r is like the x. Do you understand? So then when you differentiate a, what do we get? We get d. 2 and pi is a constant because 2 is anyway a constant, but the pi is also a constant. Pi is a value that you get in the cal, right? Pi is not a variable. Remember, you need to understand that 2 is definitely a constant. Pi is also a constant. Pi is 3.14 to some value in the cal. That is a number. So it's a constant. It's not a variable. A variable is a person who is changing. Now radius is something that will change, right? Radius is something that can change. So when the radius changes, the area will change. But 2 is something that is going to stay like this. Pi is a value that is fixed. Pi is a known value that is fixed. So that doesn't change. Do you understand? Variables are values that variables are things that can change. They vary. That's why they are called variables. Okay, so dA by dr here, because basically it's like a is y, r is x. So dy by dx is dA by dr. We just do the same story but by using different letters. Okay, so 2 and pi will stay aside. Like you have, say you have a 10 here, so you keep the 10, right? Leave it aside like that. Likewise, 2 pi will stay. Differentiate the r. What happens when you differentiate the r? Like you differentiate x, it just becomes differentiation of r gives you simply 1. When you differentiate x, you get 1, right? Just x. Likewise, just r is 1. It's simply you're changing letters, nothing more than that. The y is replaced by a, the x is replaced by r. Okay, so basically your dA by dr is 2 pi. Okay, third question, try the third one. Given that r equal 12 over t, find the value of dr by dt when t equal 3. Okay, so r equals to 12 over t. Find the value of dr by dt. Once again, do you realize r is like your y here? Can you see that t is like the x here? So we have here r equals 12 over t. So when you say r equals 12 over t, what happens? Can we differentiate while t is in the denominator? No, right? So we need to bring t to the numerator. Okay, remember you cannot just differentiate t in the denominator and put a 1. That is completely wrong. To differentiate, always your variables must be in the numerator. Okay, in P2, in the P2 level of differentiation. So R is like your y. and t is like the x here. So first let's rearrange r equals 12 times t to the power minus 1. Is that okay? 12 times t to the power minus 1. So we get here dr by dt. Is that okay? dr by dt equals, so what happens when you differentiate 12 times t to the power minus 1? When you differentiate, we get minus 1 t to the power minus 2. That's okay, right? You bring the power forward, you subtract 1 from the power. That's what we do when we differentiate, right? So basically dr by dt gives you minus 12 t to the power minus 2. Okay, and then what I think you can see in this question, they've gone a little bit far. Like what have they said here? They're asking you to find the value of dr by dt when t equals 3. So this is something a little bit new. Now they want you to actually find the dr by dt value when t is 3. So what do? Take your t value, replace the t value with 3. Okay, so let's replace the t value with 3. dr by dt minus 12 times, replace the t with 3, 3 to the power minus 2. So simplify, minus 12, 3 to the power minus 2 is over 3 to the power plus 2 over 9. So minus 4 over 3. dr by dt answer when t equal 3 is 4 minus 4 over 3. Okay, try the fourth question also. We'll try the fourth one and we'll go for the sixth one afterwards. Try this one. Question number 4. The surface area A square centimeter of an expanding sphere of radius r centimeter is given by A equal 4 pi r square. Can you see? The surface area A of an expanding sphere, which means the sphere is growing in size. Okay, the radius, the sphere grows in size. So you understand when the sphere grows in size, the area also will increase, isn't it? So they ask you find the rate of change. Find the rate of change of the area. With who? With respect to what? With respect to the radius. Now I hope you guys understand when we say dy by dx, what do you mean by dy by dx? dy by dx means the rate of change of y with respect to x. That's what we mean by dy by dx. Are you with me? So you can write this down. dy by dx means rate of change of y with respect to x. This is the meaning of dy by dx, like in context. So likewise, they are saying here, find the, what are you supposed to find? Find the rate of change of the area, which means what? Rate of change of the area with respect to the radius. What are you supposed to find in this fourth question? So according to that information, you are supposed to find what? Find the rate of change of area, which means with respect to radius. So area means we use the letter A, right, for area. And for radius, we use the letter R. So d by d what? dr by dA or dA by dr? It's dA by dr, rate of change of area with respect to radius. Do you understand? So this is what you need to find. You're supposed to find dA by dr. Find dA by dr when radius is 6 centimeters. Can you see? You are find dA by dr when radius is 6 centimeters. So they have given you the area equation. Area equal 4 pi r square. So once again, area is like a y variable. It's a variable. 4 and pi are constant. 4 is definitely a constant. Pi is also a fixed known constant. Okay, r square is your other variable, like x square. So basically, you have differentiate and find what? dA by dr. So dA by dr, when you differentiate dA by dr, 4 pi will stay here, right? 4 and pi stays, while r square differentiates to give you what? 2r to the power 1. 2r to the power 1. So dA by dr gives you 4 pi into 2r is 8 pi r. Is that okay? 8 pi r. And then we are not done. They ask me to find dA by dr when radius is 6. So input r is 6. So when r is 6, dA by dr equals 8 into pi into radius is 6. How much is it? 48. Pi. Leave your answer in exact form. They haven't asked you a decimal, so we normally keep our answer in exact form. Okay, shall we move to question number 6? So this is the first one now. This is where the real questions start. Now all the other questions we did were kind of like like getting you ready with the, like it was not very tough, but you have normally in your area question, in the differentiation question in the P2 paper, you always get a show that. Okay, so this is the place where we start with those show that questions, and it's only going to get more and more tough. Okay, so let's try doing these sums. Question number 6. A rectangle garden is fenced on 3 sides, and the house forms the 4th side of the rectangle. Okay, so first thing is you need to draw a diagram. You need to draw a diagram and mark all these things. Okay, what are they saying? A rectangular garden. Okay, we have a rectangular garden. So draw a rectangular garden. A rectangular garden is fenced on 3 sides. So the garden has fences on 3 sides. Then what is the 4th side? The 4th side has the house, right? A rectangular garden is fenced on 3 sides, and the house forms the 4th side of the rectangle. Do you understand? So this house is there here. So this side you have the house. That means we don't have a fence here. Okay, so this side we have the house. So this is your fence. Fence is there only on 3 sides. Are you with me? Fence is there only on 3 sides. Now they are saying, given that the total length of the fence is 80 meters. Okay, so what is it? The total length of the fence is 80 meters. Show that the area A of the garden is given by the formula area equal y times 80 minus 2y, where y is the distance from the house to the end of the garden. Do you understand who is y? Should I mark y on to the length side or y on to the width side? According to what I have done. No, you can't say it doesn't matter, because they say here, they say it matters here, because they say here very clearly what? Y is the distance from where? From the house. This is the house, right? Y is the distance from the house to the end of the garden. So from the house to the end of the garden, the distance that you use for your fence. So this is your Y. Do you hear me? You can't use Y to the other side. If you use Y to the other side, you will not get to show that. So Y is the distance from the house to the end of the garden. Okay. So then you are supposed to get this show that for the area. Are you all with me? So what we do is, for the other side length, we will use another one. We need to, of course, to find the area, I need to know the length and width. So for the width, shall I use X here? Okay, so I'll show that is in terms of Y. Let's try it. What do we know about? There are two things we know. Number one is we know the length of the fence. What's the length of the fence? 80. The length of our fence is 80. So according to this diagram, you know, fences, they have put the fence to 3 sides, which means, how do I get the length of the fence? You know, if this is Y, the other side is also Y, right? So the length of fence is, what is the length of the fence? 2y plus x, y plus x plus y, or 2y plus x, right? And then what is the length of the fence? They have given you the length of the fence, right? The length of the fence is 80 meters. So 80 equal to y plus x is your equation number 1. Can you see? It's clear. The next thing you should do is now what? We need to get the show that for what? We are trying to get the show that for the area, right? So area equals to what? Length into breadth. What is the length into width here? Length is x, width is y. Are you with me? X into y. So what is x? But we need to actually get the show that now you can see the area show that is in terms of y. Do you see that the area show that is in terms of y, which means I need to get rid of what here? I have to get rid of the x here. Are you all with me? So how can I get rid of this x here? How do I get rid of the x here? So we can go into the other equation, the one that we proved earlier. And from here we can make x a subject. Who is x then? From the above equation we get x is 80 minus 2y. So can't we replace that x here? We can write x is 80 minus 2y, and then multiply by outside you have another y. Do you agree with me? So do you can you see we get to show that equation area equals y times 80 minus 2y. It's the same thing then. Y here or the other side, it's the same thing. So area is y times 80 minus 2y, and we get the show that. So you need to be able to do something like this. We always get two equations. So here, one for the perimeter, the length of the fence, the other one for the area. So this is how these sums always go. They give you to make two equations. And then you have to get to show that by removing one variable. Okay. So now try part B. Karanna. Part B, they say, given that the area is a maximum for this length of fence, okay, given that the area is a maximum for this length of fence, find the dimensions of the enclosed area and the area which is enclosed. Okay, now what do they say here? The area is a maximum. What do you understand when the area is a maximum? Now you have an equation that's relating the area and the length, right? The relationship between area and y is given to you. So they are saying the area is a maximum. Now in the previous section, what did we learn? We learned about these things for stationary points, right? In stationary points, what we learned about these, what are the stationary points we learned? The minimum, the maximum, and the point of inflection. Can you remember? So at any stationary point, or like now we are here are interested about the maximum. What happens? At the stationary point or at a maximum, your gradient, your dy by dx, in this case, the dy by dx becomes equal to 0, isn't it? The dy by dx becomes equal to 0. Can you understand? So then when they say here the area is a maximum, so that's the exact same thing that you need to do. You have to find the value, you have to find the value at the stationary point. Okay. So what we'll do here is part B. Before you go to get the differentiation, I think you can see we can't have a, we can't differentiate while there's a bracket here. Shall we open the bracket? Open the area equals y into 8 is 80y minus y into 2y is 2y square. Is that okay? 80y minus y into 2y is 2y square. Now, when you look at this function itself, this is a what function? It's a quadratic function. Can you see there's a y square here? There's a y here. It's a quadratic function. And what quadratic is it? You know, we have two types of quadratic, a minimum quadratic and a maximum quadratic. So looking at your y square, the y square has a negative 2 coefficient. So if your x square coefficient, in this case it's y square, it doesn't matter because you understand here a is like the y axis and here the y is the x, right? Do you understand? So this is basically like y equals 80x minus 2x square because they have just switched letters. Okay, remember when they give like this, it's just switching letters. We have to do the exact same thing we did earlier. Okay, so this is like y equal 80x minus 2x square. Okay, it doesn't matter whether what letters they use. The theory is the same. So this is minus x square means it is a maximum graph. The x square coefficient is what determines whether it's a maximum or a minimum. A positive means a positive x square is a minimum, a negative x square is a maximum. So this is definitely a maximum. So then we, so do we need to get to verify the point? Do we need to verify it? No, we know surely this is a maximum point. Okay, the only thing we need to do is just to find the maximum place. So let's get it. What do we need to do? Let's get the differentiation dA by dy. dA by dy. Let's differentiate. What do we get? 80y differentiation is 80. 80y differentiation is 80 minus 2 times this is 4y. 80 minus 4y. So we get here dA by dy is 80 minus 4y. So at the maximum point, you can even mention here, this is a quadratic maximum graph. Then you know that this is a, you know that you only have a maximum turning point here, right? So at maximum point, your dA by dy becomes equal to 0. So 80 minus 4y equals to 0 and I get 80 equals to 4y. So y equals 80 divided by 4, which gives you how much? 20. 80 divided by 4 is 20. Okay, so I think there was a little bit of a lag. So I hope you all are able to understand. For the quadratic maximum, what I did was, I mean, at the stationary point, we realized it's a maximum because of the negative y square, right? The negative the coefficient of the y square tells us it's a maximum, a quadratic maximum graph. Therefore, we know the turning point is a maximum. So I differentiated, and according to what we learned in the previous section, we know that at the stationary point, the dy by dx, in this case, the dA by dy must be set to 0. And we know in this case, the stationary point is definitely a turning point because we have a quadratic maximum graph. So I set it to 0. I set my dA by dy to 0 and I get the y value here. I get the y value here as 20. So when I get the y value here as 20, so that is the value over here, right? Now they are asking us to find what? Find the dimensions of the enclosed garden. What do you mean by the dimensions? Dimensions means both the length and the width, right? So what's the length and the width? So what is the x value? Because dimensions means I need the y value and also I need the x value. How do I get the x value? The x value we can take by using the equation x is 80 minus 2y. X is 80 minus 2y. Let's go there. X equal 80 minus 2y. How much is x? 80 minus 2 times y is 20. How much is it? 80 minus 40, which means x is 40. So these two dimensions are pretty special. Why? Now, you know, for the length to become 80, I mean, we could have had many dimensions, but this x and y is particularly special because this x and y will make sure that you have what? It will make sure that you have the maximum area. It will make sure that you have the maximum area. Okay, and they want you to also find the area which is enclosed. So get the area which is enclosed. So area, if you want, you could use the equation area equal y into 80 minus 2y, or else you could simply go really easy method here. Area is x into y, length into breadth. Do you understand? Area is x into y, right? Or else you could use this substituted equation. Anyone is fine. Any one of the two is fine. So area of the enclosed garden, I'll use x into y. If you want, you could use the equation we derived. So x is 40, y is 20. How much is it? 40 into 20 is 800. So I think we have in square meters, right? 800 square meters because our perimeter was in meters, right? Yeah. The length of the fence is in 80 meters. Therefore, your perimeter, because it's in meters, your area should be in square meters. Okay, is this okay? So dimensions are also 20 meters and 40 meters here. Okay, shall we move on to the next one now? Okay, so now we'll try question number 7. Look, a closed cylinder has total surface area equal to 600 pi. Okay, now to do these questions, you need to actually know the surface area equations of a cylinder. Now here they are referring to a cylinder, right? So you need to remember all those equations. Surface area of cylinder, I think we also have the volume of the cylinder, right? So you need to remember those equations. So in a cylinder, what is the equation for the surface area? Surface area of a closed cylinder. Closed cylinder means you have both the lids. So we know the curved surface area of cylinder is what? What is the curved surface area of a cylinder? 2 pi RH. Now the thing is you need to remember these equations. Okay, so what's the total surface area of a cylinder? Total surface area means the curved surface. Curved surface means this around part. The part that is going around the cylinder, this is the curved surface. And you have the two circular lids, one up and one down. Can you see? So each of there are two circles. The total surface area includes the 2 pi RH, which is the round part around the center, plus the two circles. One circle is pi r square, the area. So there are two circles, therefore 2 pi r square. So this is the equation you learn in your O-level exam, 2 pi RH plus 2 pi r square. Also, you must know the volume equation of a cylinder, volume of a cylinder. So by the way, here R refers to the radius, okay? R is the radius, H refers to the height. The volume is, the volume of a cylinder is pi R square H. You must remember all these equations, okay? So then, they are saying a closed cylinder has a closed cylinder in the sense like both the lids are there. In an event, if they use the word open cylinder, what does it mean? An open cylinder means the top lid is not there. So that means you only have the bottom lid. So you have the curved surface and 1 pi r square if it's an open cylinder. I mean, if it's open only at the top. If they say a fully open cylinder, if both the lids are not there, then it's only 2 pi RH who contributes for the surface area. Okay, so here closed cylinder means I have the curved surface plus the two lids. Okay, so they have told you the closed cylinder has a total surface area equal to 600 pi. Are you with me? So that means you can write the total surface area equation. Total surface area equation is 2 pi RH plus 2 pi r square. How much is this answer equal to? They say this answer is equal to how much? 600 pi. Are you with me? Total surface area is 600 pi equal to 2 pi RH plus 2 pi r square. Let's simplify this equation a little bit. Okay, so then what we do here is, I think you all can see that pi is, now there are three terms here. Do you see there are three terms here? 600 pi is one term, 2 pi RH is one term, 2 pi r square is another term. Do you see that all these three terms have a common letter? You can see that pi is there to everyone, right? So shall I divide the whole equation by pi? Actually, I could divide the whole equation by 2 pi. Because you can see even 2 is common, right? I could divide the whole equation everyone by 2 and I can divide the whole equation everyone by pi. So it cancels out. So 600 divided by 2 is 300. Pi will cancel out. 2 pi RH, the 2 divides the 2, the pi also cancels out and I remain with RH. Here also 2 and pi cancels, I remain with R square. Do you agree with me? So this is what I have right now at this point for the, this is the surface area equation. Let's keep it like this. And we are trying to get the show that for the volume, right? So leave a little bit of space here because probably I'll be trying to make either R or H the subject here, okay? So I'll leave a little bit of space here because to get this show that probably I'll have to make one of these. I'll have to use this equation again, okay? So they are asking to show that the volume of the cylinder. So how do we write the volume of the cylinder? So what is the volume of a cylinder? I gave the equation to you all. Volume is pi r square h. So volume is what you need to show. Pi is a constant, r square will be there. So I think you can see in the volume equation they have, do we have a value for h? Do we have h in the show that? The volume equation that they have given is completely given in terms of pi and r. There is no h here, which means what we need to replace our h in the volume equation. We need to replace this h. How do we replace the h? So I am going to go back to the first equation and what? Make h the subject. I'm going to make h the subject. So I get here 300 minus r square equal rh. Do you agree with me? Then making h the subject, the r comes to the other side as division. 300 minus r square divided by r. Do you agree? That is h. So I'll replace the h here. Pi into r square into the h value. The h value is 300 minus r square over r. Can you see? So I could remove out. I think you can see now when I go with this equation, I could cancel out an r because r is down here. R can cancel with one r up here. Do you see? So I end up getting here pi times r times 300 minus r square. Let's try to get the show that pi r into 300 gives me 300 pi r minus pi r into r square is pi r into r square is r cube. So volume equal 300 pi r minus pi r cube. Okay, so that is the show that. Can you see we got the show that exactly? Okay, so this is how you get the show that. Always even in your exam questions, you'll always have to work with two equations. Get two equations and use one equation to substitute to the other. To remove the variable you don't want. Now in this case, I needed to get rid of the h. So I used the first equation to get rid of the h. Okay. Then the next thing we do is find the maximum volume of such a cylinder. How do we find the maximum volume? How do we find the maximum volume of such a cylinder? So obviously maximum means they expect you to do what here? Whenever the words maximum, minimum is used, you must remember stationary points, which means what? Differentiate and set it to 0. That's what we mean by maximum or minimum. So let's do it. So let's differentiate dV by dr. Okay, there are two parts here. 300 pi is a constant. So differentiate the r, you get 1, right? 300 pi r differentiation is 1 minus pi r cube. So when you differentiate pi r cube, what do we get here? Pi is a constant, pi stays. R cube differentiation is 3r square. You see, r cube differentiation is 3r square. So at maximum, they have not asked us to verify that it's a maximum. Sometimes they ask you to verify. In this case, they haven't. So I can just continue. If they ask you to verify it's a maximum, you remember in the previous section, we went for the second derivative. Can you remember? Okay, so anyway, at maximum, you know your dv by dr is set to 0. So 300 pi minus pi into 3r square is equal to 0. So let me take it to the other side. 300 pi equals 3 pi r square. So pi to pi will cancel. R square equal 300 divided by 3, right? Which means r square is 300 divided by 3 is 100. So r equal square root of 100 and we get r is 10. So, you know, obviously we should use only the positive value here. We are talking about a radius. So you don't get plus minus. We don't need to consider the negative r value. Okay, so is this what they want? So basically what I have here is the r value at the maximum. Is that what they ask us to find? Read the question. They ask us to find the maximum volume of such a cylinder. The maximum volume, not the r value who gives you the maximum. So how do I find the maximum volume? Substitute the r value into the volume equation. The volume equation is 300 pi r minus pi r cube. Replace the r with 10. 300 pi into r is 10 minus pi into r is 10 cube. R cube is 10 cube. So I end up getting here volume equal 300 into 10 is 3000 pi. 10 cube is 1000, right? So into minus 1000 pi. 3000 pi minus 1000 pi is 2000 pi. 2000 pi, and this is in what? This is in cubic centimeters. Because the radius is in centimeters. This is cubic centimeters. 200 pi cubic centimeters, because they have given us the r centimeter, right? They have given us where r is in centimeters. Okay, so we can just leave it like this here. So volume is 200 pi cubic centimeters. Try the next one. Okay, so now let's move on to question number 8. A sector of a circle has area 100 square centimeters. Show that the perimeter of this sector is given by this formula. Okay. So what is the equation for area of a sector? Question number 8. Area of a sector. The equation we use is half r square theta, where theta is in radians, right? This is the equation we use. Area is given to you as 100. Can you see? The area of the sector is 100. Half half r square theta is unknown, right? Yeah, we don't need to use pi r square. We can use directly half r square theta for the area of a sector. So this is the equation in radians which you learn in P2, which you learn in P1. You learn this in P1. Half r square theta is directly the equation that you can use. I mean, basically you use in O levels theta over 360 into pi r square. Is that what you use? That you can't use, that is in degrees. If you want to use theta in radian, then theta over 2 pi into pi r square. The area equation pi to pi cancels and you get half r square theta. Okay, so that's the equation to use where your theta is in radians. Okay.
Theta is for 180 degrees, right?
Okay, then right. So 100 equal half r square theta. So this is our first equation. We are supposed to get the show that for the perimeter, right? I think in the perimeter show that I can see everything is in terms of r. Do you see everything? Everyone is in terms of r. So this kind of gives me an idea that I need to get home the subject. If I want my final answer to be in terms of r, I probably will have to remove the theta. Right, so I'll make theta the subject here. Otherwise, if you're not sure, you can leave it and go for the next part. Write the perimeter and then see which variable to remove. So I can understand when I look at the perimeter equation, it's only given in terms of r. So they remove the theta. So I'll make theta the subject here. 100 the half, the 2 goes up over r square equals theta. So 100 times 2 is, it's giving me 200 over r square is equal to your theta. Is that okay? So now let's write the equation for perimeter. So perimeter of the sector, there are how many parts? So perimeter means you have to include all the borders. So perimeter includes the arc length plus the radius, and there's another radius. Arc length plus 2r. Arc length is this curve length plus the radius and plus the radius. So arc length also you have the equation you learn in P1. Arc length directly, the equation you learn in P1 is arc length equals to r theta. Okay, you don't need to use theta over 316 to 2 pi r, that's in degrees. So in P1 you directly learn the equation for arc length in radian. Perimeter is the arc length is equal to r theta plus r is 2r. So all you have to do now is replace the theta with 200 over r square and you should get your show that.
Yeah, teacher.
Okay, so then perimeter is equal to r times. So obviously I can see in the show that there is no theta. I have to get rid of the theta here. So I'll replace r times the theta with 200 over r square plus 2r. I think we get the show that, are we? 200 over r square. So this is r over 1. You can cancel one of the r's here, right? So we get 200 over r plus 2r, which is our show that. Okay, which is our show. Then they have given you some reason here r is greater than root 100 over pi. So don't be, you don't need to be worried about this. This has an implication on the next part. Okay, so you might be wondering what is this. This is, you have to get the show that for this perimeter. Perimeter is equal to 200 plus 200 over r plus 2r. So we got the show that. Okay, so let's go to part B, and there I think we can see this where this is applied. Part B they say, okay, part B they say find the minimum value for the perimeter. Okay, so to get the minimum value or maximum value, basically it's a stationary point, right? So you need to set your dy by dx. In this case, the dp by dr, you have to set it to 0. Before I find dp by dr, you understand I can't differentiate when my r is there in the denominator. First thing is we bring r up. So when you bring r up, the r comes up as r to the power minus 1 plus 2r. You can see I didn't differentiate. I first made the equation. I made it possible to differentiate. Then let's do, now we can differentiate dp by dr. When you differentiate 200 r to the power minus 1 is minus 200 r to the power minus 2. Bringing the minus 1 in front and subtracting 1 from the power plus 2r. 2r differentiation is 2. So okay, 2r differentiation is 2. So now for the minimum or maximum stationary point, you set your value, you set the dp by dr to 0 at minimum. Let's say here it's a minimum. dp by dr is 0. So we get here minus 200 r minus 2 plus 2 equals 0. So basically minus 200 goes to the side as plus 200 r to the power minus 2. R to the power minus 2 is a negative power. You can bring it down and make it a positive power. Do you agree? R to the power minus 2, you can bring it down. Then it's r to the power plus 2 and it's a positive power. So bring r square to this side. 2 times r square is 2r square equals 200, which gives me r square equals 200 over 2. Is this okay? R square is 200 over 2. So which gives me r square is 100. Therefore, r is root 100, which is 10. So I directly get r is 10. Okay, plus or minus 10, but we will take the, obviously we will take the plus value. So what do they ask us to find, by the way? They're asking us to find the minimum value for the perimeter. So let's get the minimum value for the perimeter. So the minimum value for the perimeter will be the minimum value for the perimeter is gonna be what was the perimeter equation we found? 200 over r plus 2r, right? Replace r with 10. 200 over 10 plus 2 times 10. 200 over 10 is 20 plus 20. Your minimum perimeter is 40. Okay. Okay, I think we did not get to use this r is greater than 100 over pi, right? Where shall we look into this? Wait, let's see what this is about, because in the part A in the show that I think we got the show that, but there was something they are said this where they said that r is greater than root 100 over pi, right? So shall we check about shall we check on that? So what are they saying here? R is greater than root 100 over pi. Just look into it. How do we understand that? Okay, so to get this show that what we need to do here is, I mean, to understand this r is greater than root 100 over pi. Okay, it's something like this. Now you know in your now you know here in our sector we have the center angle is theta, right? Because this our center angle is theta, right? And what do we know about now? You know the full circle angle in the center is how much? For the full circle angle in the center is what? You have a full 360, right? For the full circle, the angle in the center is 2 pi. Do you agree with me? So what do we know? We have a sector. We have a sector and we have an angle theta. What can you say in comparison about the sizes of theta and 2 pi? Theta is a sector. Sector is a part of a circle, not a full circle. So in comparison, when you compare theta and 2 pi, who is larger and who is smaller? Who is larger? 2 pi is definitely larger, right? 2 pi is the full circle. It consists of the full 360 degree, while theta is only part of the circle. Theta is only part. Okay. Full circle is 2 pi. Now I'm trying to get this show that here. This explain you how r is greater than root 100 over pi. So definitely we understand that theta is lesser than 2 pi, isn't it? So if theta is lesser than pi, then the next thing we can say about this one is the area of our sector. Do you agree that the area of our sector is definitely less than the area of the full circle? Now the full circle area is pi r square, right? Do you agree the full circle area is pi r square? And do you agree that the area of our sector is less than pi r square? Because our sector consists of only this one part, while the circle is the whole thing. So the area of your sector is less than pi r square. Do you agree with me? Area of sector also, do we know it or not? The area of the sector is given to you, right? The area of the sector is how much? 100. So that means 100 is less than pi r square. Do you see it? So 100 over pi. R square is greater than 100 over pi. And therefore, can you see what happens here? You take the pi down as a division. Pi is a constant. Pi is a positive constant. We take it down as a division. And therefore, you can write the next step here, right? So therefore, R is greater than root 100 over pi. So this is another way of showing how R is greater than root 100 over pi. Like how that value, like how they definitely got this value. Okay. Okay, now let's move on to question number 9. A shape consists of a rectangular base with a semicircular top as shown. Given that the perimeter of the shape is 40, show that its area a square centimeter is given by this formula. Okay, so the thing is to get the formula again. It relates what? Area and perimeter. So all you have to do is to make two equations relating its area and its perimeter. So let's try. The first thing is we know it, they have given us the perimeter. Shall we write something about its perimeter? So because it is a semicircle, you understand here that if this is R, the other side is also it's also an R, right? Which means the total length of this side is 2R. Do you agree? The total length of this side is 2R. Okay, I think this particular length we really don't know, so I will name it as X. Okay, because we have no way of now you cannot take this side as X because it's not a radius of the semicircle, it's not anything. It's a you have here a semicircle and a rectangle. So for the rectangle, the length of the rectangle is 2R because we can use the diameter of the semicircle. You understand? However, the width of the rectangle we have no idea. So you will have to definitely give it in terms of an unknown letter. Okay, make sure you give an unknown letter. Okay, so let's write the perimeter. So first thing for perimeters, I'll write the arc length. To get the perimeter, I'll go with the arc length. What is the arc length? Arc length of a semicircle. Arc length is r theta. Normally we use r theta, right? So what is the radius? Radius is r. Theta is, because it's a semicircle, theta is pi, 180. A semicircle means 180 degree, which means in radians, the theta is pi. So you get here pi r. Arc length is pi r. You understand, I mean, you can even understand through common sense. A full circle length is 2 pi r, half circle is just half of 2 pi r, which is pi r. Okay, so that only gives me what? That just gives me only this arc length. It gives me only the arc length. Okay, then the next one, let's write the perimeter. So what is our perimeter? Add all the borders. Perimeter is equal to the arc length pi r plus what else do we have? The x. Okay, all the outside borders. The x, the 2r. Okay, by x I mean this. Okay, by x I mean this length. So x is this length. Okay, x is this length plus 2r. By 2r I mean this length. So there is the 2r plus the other length. You can see there's one more length remaining, right? So this remaining length is the same as the width of the rectangle. Again, it's another x. Do you agree with me? So again, it's the other x here. So it's this x here. Do you see? So perimeter is consisting only of all the outside borders. Do you take any inside lines? No, only the outside borders. And perimeter is given to you as what? The perimeter of the shape is 40 centimeters. So 40 equals to pi r, x plus x is 2x plus 2r. Are you with me? So I have a feeling now looking at the area equation, it's all given in terms of r. So I think we don't need any x here. X is also a variable that we input. So I think, what's the best thing to do here? The best thing to do here is to remove the, to subject the x, because x is the thing that we don't want. We can remove x when we substitute the other equation. So 40, I'll take the pi r here minus pi r, and I'll remove the plus 2r as minus 2r equal to x. And that gives me x equals 40 minus pi r minus 2r divided by 2. Do you understand? 40 minus pi r minus 2r divided by 2. This gives you the x. Okay, that is what I used. I got this from by using the perimeter. So now what we'll do is we'll create our area formula. Shall we create the area formula? So what is area? Here you can see area is made up of two sections, right? You have a half circle and you have a rectangle. A half circle and a rectangle. So area, the total area is equal to area of semicircle plus area of rectangle. The area of semicircle plus area of rectangle. So area of semicircle is what? Area of a circle is pi r square. Area of a semicircle is half of pi r square, right? We don't need, if you want, you could use the sector equation half r square theta and replace theta with pi. Or equation of a circle, area of a circle is pi r square, semicircle is half of pi r square. Plus the area of the rectangle, length into breadth. What's length into breadth for the rectangle? Length is 2r, breadth is x. Can you see? 2r multiplied by x. Do you agree with me? 2r multiplied by x. So I get here half pi r square plus 2rx. Okay, so now the show that, you can see the show that has no letter x in it. I have to get this particular show that. So what do? Replace our x. We have the x value here. Replace the x with what we found above. So replace the x with what we found above. Half pi r square plus 2r times x is 40 minus pi r minus 2r divided by 2. 40 minus pi r minus 2r divided by 2. So then we can cancel off 2 and 2. Do you agree? We can cancel out 2 and 2 here. Because this is one term. Be careful. You must understand this is one term and this is the other term. Okay, remember there are two separate terms here. Okay, so remember these are two separate terms. Half pi r square is one term. 2rx is a completely another term. Okay, so half pi r square stays here separately, and this person, I think you need to understand this 2r is 2r over 1. So you cancel the 2 to 2. Okay, you don't multiply 2r with the 2. That is wrong. Okay, so the 2 to 2 cancels. Now let's Simplify, I get here half pi r square. And here outside the bracket, I'm just having a r, isn't it? Shall I open the bracket with r? Because I want to get the show that. So r times 40 is 40r. R times pi r is minus pi r square. R times minus 2r is minus 2r square. Do you agree with me? So this is what I get. Now to get the show that, check whether there are like terms. I can see the 40r. Now in my show that I have 40r. I have 40r here. Minus 2r square. Yes, I have minus 2r square here. So there is a minus pi r square over here. So do we have some like terms here? I think we can see half pi r square and minus 1 pi r square. Do you see that these are two like terms? Plus half pi r square and minus 1 pi r square. These are two like terms because both of them are pi r square, pi r square. So you can bring them together and add them. Half minus 1, you can add them together and add how many pi r squares you have. Plus half and minus 1. Plus half and minus 1 gives you minus half. Okay, so you can type it in the calculation. So I end up getting here minus half pi r square when I take these two terms that I underline. And then I have the plus 40r minus 2r square. Rearrange in the way that we got. Okay, so now what we need to do to get this show, that is simply to rearrange, right? You can see I have got every single term when I add these two terms that I underline here because they are two similar terms, half pi r square minus 1 pi r square. It gives me a half minus 1 is minus half. So I end up getting minus half pi r square. Plus 40r minus 2r square. Shall we rearrange? So when I rearrange, I get plus 40r minus 2r square minus half pi r square. Okay, is that okay? So that is to show that. Hence, find the maximum value for the area of the shape. Okay, how do we find the maximum value? So whenever we come to the word maximum minimum, it means what? We have to differentiate, right? So I got my area equation. Is there any r who is in the denominator? Do we have any r who is there in the denominator? No, right? So I can directly differentiate. Shall I directly differentiate? So dA by dr, differentiate. What do we get? 40r differentiation is 40. Do you agree with me? Minus 2r square differentiation is minus 4r minus half into pi. Half and pi are both constants. R square differentiation gives you 2r to the power 1. Do you agree? Half pi are constants, they wait, while r square differentiates to give you 2r. Okay. Okay. Yeah, we can cut the half and 2. Okay, so we get here dA by dr equals, yeah, you could cut it out at once. 40 minus 4r, half and the 2. This is over 1. So the 2 to 2 cancels. We get 40 minus 4r minus pi r. And then at maximum point, your dA by dr is equal to 0. So basically your 40 minus 4r minus pi r equals to 0. So then what we'll do is we'll take the minus 4r and pi r to the other side. Minus 4r goes as plus 4r plus pi r. The reason why I took these two to the other side is to make them, because both of them have the letter r. And I want to make r the subject. So when I make r the subject, I can take r out as common and I get r times 4 plus pi equals 40. R equals 40 over 4 plus pi. Okay, so this is my r value. Okay, so now they are asking us to get the r value. No, right? They are asking us, hence find the maximum value for the area of the shape. They are asking you to get the area of the shape, which means what? Substitute the r value into the area equation. Substitute this r value into the area equation to get your maximum r. Okay, so let's do that. Okay, so now what we need to do is we need to substitute the r value into our area equation to get the maximum area. So what I'm trying to do is I'm trying to get the exact answer that they have given it at the back of the book. At the back of the book, they have given us, because otherwise when we substitute 40 over 4 plus 5, the simplification is quite tough, and you will most of the time, or you would just end up getting a simple decimal answer, right? So let me show you what I mean here. Now I want to get the area answer. Let's substitute r as 40 over 4 plus pi, right? R is 40 over 4 plus 5 minus 2 times r is 40 square over 4 plus pi. We square the whole thing together. 40 over 4 plus pi whole thing square. Do you agree with me? Because it's r square. 40r minus 2 times r square minus half pi. R square is again 40 over 4 plus pi times r square. So r square is the square of this. Now, of course, the easiest option here is to type the whole thing in the cal and to get a decimal answer, okay? But however, at the back of the book, I'm taking the answer from the back. They show me the answer as 800 over 4 plus pi cubic centimeter. This is what they show at the back of the book. So I'm going to treat this sum as a show that, like in an event, you get such a show that in your exam, you need to learn how to simplify. Okay, so otherwise you can simply get the decimal answer, but I want you to learn how to simplify and to get your answer towards what they have at the back of the book. Okay, so let's learn how to simplify. It's quite important. So I'm going to try to get this answer which they have provided at the back. Okay, so I end up getting here area equals 40 into 40 is what? This is 40 over 1. 40 times 40, I get 1600 over 4 plus pi. Do you agree with me? Okay, look, minus this one is 2 times the square. The square applies to both up and down, right? 40 square is 1600 over 4 plus pi square. Do you agree with me? Do you agree with me? Minus half pi times 40 square is again 1600 over 4 plus pi square. Agreed? Let's simplify this a little bit more before I take the common denominator. 1600 over 4 plus pi. 1600 over 4 plus pi. Minus 2 times 1600 is 3200, right? 3200 over 4 plus pi square. The half and 1600 can cut off, right? 2 times 1, 2 times 8 is 16. 0 and 0. Do you agree with me? So I end up getting 800 pi over 4 plus pi whole thing square. This is okay. So now it's time to go for the common denominator. So what's the common denominator? The common denominator can be 4 plus pi. Some have 4 plus pi, some have 4 plus pi square. So the common denominator can be what? 4 plus pi square. It's 4 plus pi square. So basically you multiply here both up and down with what? Here you have only 4 plus pi. So you need to multiply both up and down with the 4 plus pi. The other two terms, I think you can see we already have a common denominator. We don't need to multiply it with anyone. So 1600 multiplied by 4 plus pi. The other two, I think we can clearly see already has a 4 plus pi square. So do we need to change anything here? No. So I can directly go minus 3200 minus 800 pi. So now work on this. So area equals 1600 times 4 is how much? 1600 times 4 is 64. 6400 plus 1600 pi minus 3200 minus 800 pi over 4 plus pi square. So I get here 6400 minus 3200 is 3200. 1600 pi minus 800 pi is plus 800 pi over 4 plus pi square. Now I can take, we can take 800 out as common, right? So then I get here 800, 3200 divided by 800 is 4. 800, when I take it out, I just get 1 pi. Do you agree with me? Over 4 plus pi square. So do you see I get 4 plus pi perfectly on top? And a 4 plus pi square is a 4 plus pi into another 4 plus pi. So because I get the 4 plus pi perfectly, I can cancel out one of them. And I can get the show that which was given at the back of the book. So 800 over 4 plus pi square centimeters. I have written here cubic centimeter, right? Square centimeters. 800 over 4 plus 5 square centimeter is the answer, and we are able to get it by so I treated this as a show that sum. Okay. Okay, so now let's go to question number 10. The shape shown is a wire frame in the form of a large rectangle split by parallel lengths of wire into 12 smaller equal sized rectangles. Can you see? So you have a wire frame, and this is a full wire frame. Okay, so everything, even inside you have wires running inside. Okay, so then they are saying, given that the total length of the wire used to complete the whole frame is 1512 millimeters. Can you see? This is all given in millimeters. I think the length is also in millimeter, area is also in millimeter. So we don't need to worry. Okay, everything is in millimeter. They are saying the total length of wire used to complete the whole frame is 1512. Show that the area of the whole shape is given by this particular formula. Okay. So then what are the two equations we need to build? One, we need to build one equation for the length of the wire that they have used to build the frame. The other equation is for the area of this whole frame. Okay, so let's talk about the perimeter. So when we talk about not the perimeter, I'm sorry, not the word is not perimeter. We are talking about the length of wire, because perimeter will only refer the outside borders. Are we talking about outside borders? No, we are talking about the total length of wire used to build this whole thing. So total length of wire will include every single wire that goes in as well. Okay, so then how many? Now you can see they have split this into the length and width into x and y. So how many x lengths are there? So you can see here x comes for each and every one of these parts, right? Do you see? Do you see that even inside you have x here? And you have again on top you have x here. So in one row I have 1, 2, 3, 4, 5, 6. The length is 6x. So that's 6x. You can see it's there again another 6x here. Again another 6x here, which gives you a total value of 18x. Okay, so length of wire. So length of wire is 18x. Length of y is 18x plus how many y? You have here y, and here you have another y, right? And do you see that the y's are also going inside like this in a similar manner? So how many y's do we have? We have how many y's? So we have here 1, 2, 3, 4, 5, 6, 7. 7 length, 7 times 2, right? In each one you have 2 y's. 7 times 2, we have 14 y's. Is that okay? So this is the total length of the wire in terms of x and y. Total length of wire is given as what? The total length of the wire used to complete the whole frame is 1512. 1512 equals to 18x plus 14y. Do you agree? So I think the whole equation we could divide to make it easier for us. Shall we divide? The whole equation can be divided by 2. Can you all divide by 2? 1512. 1512 divided by 2. What do we get? 756, right? 18 divided by 2 is 9x. 14 divided by 2 is 7y. Do you agree with me? And when you look at this equation, which particular variable should I subject? Do you think I should subject x, or do you think I should subject y? I should subject y, because the final show that is only given in terms of x. So I should definitely make y the subject and keep it ready so I can replace it in the area equation. Okay. So I get here 756 minus 9x equals 7y. So I get here, I'm getting y ready here, 756 minus 9x divided by 7. 756 minus 9x divided by 7. Okay, then the next thing is to get the area. So what is the area of the whole shape? The area of the whole shape is length into breadth. Basically, if you want, you could get the area of one rectangle, and there are 12 rectangles. Or you could take the length into width of the big rectangle. Anything is fine. Okay, so I'll take the area of one rectangle and multiply. One rectangle is x into y, right? The area of one single rectangle is x into y, and there are how many such rectangles? There are 12 such rectangles. So area is 12xy. So area is 12xy. Now it's time to substitute the y here. Replace y. 12 into x into y is 756 minus 9x. Whole thing divided by 7. Do you agree? I'm trying to get the show that the 12 and 7 will not cut, right? So let's multiply area equals, so this, let's open the bracket. 12 times 756 is, 12 times 756 is the 9072x minus 12 times 9. 12 times 9 gives me 108. X into x is x square. Whole thing divided by 7. Do you understand my simplification? I took the 12x and multiplied the bracket inside with the 12x. 12x into 756, 12x into minus 9x. And the whole thing is out of 7. Now to get the show that, you can see in the show that they've separated the 7, right? This doesn't have the 7. So separate it out. So area equals 9072x divided by 7 minus 108x square divided by 7. Do you agree with me? So 9072 divided by 7 is 1296 minus 108x square over 7, which is our show that. This is our show that. Okay, so this is show that. Next one, hence find the maximum area which can be enclosed in this way. So maximum area. Part B, right? Yeah. Part B, to get the maximum area, what do we need to do? We need to differentiate this again, right? We need to differentiate this for the first time. So we differentiate and set our differentiation of the equation to 0. So what do we get here when you differentiate? dA by dx. 1296 is allowed without any x term. Sorry, there is x term here, right? I have missed it out. 1296 x here, isn't it? Do you see the show that has a 1296x, right? Yes. So I get here 1296x. When I differentiate, I get 1296. The x differentiation is 1 minus 108 over 7. When you differentiate x square, what do you get? Differentiation of x square is 2x. Do you agree? So at maximum point, your dA by dx is set to 0. Your dA by dx is set to 0. So 1296 minus 108 over 7 times 2x equals 0. Do you agree with me? So what do we get here? 1296. Shall I move this to the other side? Minus 108 over 72x becomes plus 108 over 7 times 2x. So making x a subject, 1296. 7 comes as a division. 108 and 2 comes down, right? The 108 and 2 is a multiplication. So the 2 comes down, 108 comes down, 7 goes up. What is the x value? X value is 42 millimeters. Is that okay? It's a matter of typing it in the calc. So x value is 42. And then what we can do is we need to get the maximum area, right? Hence find the maximum area. So maximum area, thousand 296x. Children, by the way, if you want to verify, sometimes in the exam, it's common for them to ask you, verify that the answer you got in the above part is a maximum. So that is something that they ask, okay? So, actually in this question, I'll do that because that is something they ask in the exam and that is something that extra you need to learn. So maximum area, first we'll get the maximum area, 1296 times x is 42 minus 108 over 7 into x is 42. X square is 42 square. Okay. This is 1296, right? Okay, so you can use this in the calculator and get your answer. If you want, by the way, you could get your y value. Now, since you have your x value, you could go over here and substitute the x and get the y value and also apply area is 12xy and also get the area. That is also perfectly fine. Okay, so what is the answer you get for the area here? You get here 27,000 216 square millimeters because he is going in millimeters. Is this correct? Okay, check this answer 27,216. Okay, so another thing they ask you in the exam, as I was mentioning you earlier, another thing they ask you in the exam is they ask you another part. They ask you verify that the answer obtained above is a maximum. So this is something that they ask you and you need to be able to prove it if they ask you. So how do you verify that the answer that we obtained above is a maximum? So basically this is the thing we learned in the earlier part. When you find a stationary point, we can use the second derivative to test whether you have a maximum or a minimum. Do you remember? So what's our first derivative? dA by dx. dA by dx was what? We got dA by dx, right? 1296 minus 108 over 7 into 2x. Can you see? I think we could simplify this a little bit further, right? Shall we simplify 108 over 7 into 2x? Can you simplify the answer here? 1296, 108 times 2 is 216 over 7x, right? We can multiply 108 and 2 and make it a little bit simpler. So this is our dA by dx. Now I can go for the second derivative. So when I differentiate again, I get d square a by dx square, the second derivative, d square y by dx square. Similar to that, d square a by dx square. 1296 is alone. When you differentiate, it becomes 0 minus 216 over 7 into x differentiation is 1. Okay, so we don't even need to substitute the x value because directly you can see for d square a by dx square, I get a what answer? I get a negative answer. So if you have a negative answer, it means the stationary point is a maximum. Definitely the point that you obtained above should definitely be a maximum. This is how you verify. Okay, and when they ask you to verify your answer, you must be able to verify it by using the second derivative. Okay, so if it's a minimum, your second derivative should be positive. If it's a maximum, your second derivative value should be negative. So in here, I didn't get to substitute the x value, but most of the time when you go to the second derivative, your second derivative will also have an x. When you have the x, you must substitute the x value which you got on the earlier part, substitute the x value and show whether you have a positive answer or a negative answer and decide accordingly. Okay. Right, so this is the end of this chapter. Okay, so we are done with this chapter. Yes, so I hope everything was clear. Okay.